Okay, first lesson on quadratics. We're going to do a little precursory explanation of what a quadratic looks like and what special points are located in them. Then we're going to talk about the three forms, why we have three different forms of the quadratic. Why? Now, looking at this, we're going to take a look at the first part here. And let's draw a sketch of a quadratic, okay? Now, so let's give it the first magic point called a vertex. So I'm going to make my vertex right here. Okay. Now we're going to give it something called a y-intercept. Okay. And then we're going to give it something called a root or an x-intercept. And we're going to try to sketch this bad boy here. And let's see how bad I can hit those. So we have a really wide vertex here, wide parabola, or a quadratic. My first points, let's mark off some of these points here. And give them some names real quick. Alright. Now, let's take a look. The points, what's their names? Okay, this one here, the black dot here, it's called the vertex. Now the vertex has an x-coordinate and a y-coordinate, has two parts. Okay, so that's pretty straightforward. The next point, which is the blue point, is called our y-intercept. Now our y-intercept here, our y-intercept is in the form when x is 0 and we have a y value. Okay, so the input is 0 and the output is some value that is the y value. Though the last one we have is the twins here. Those are called the roots, or zeros, or x-intercepts, or solutions. So these have a bunch of names, These can be called roots. These can be called zeros. These can be called x-intercepts. These can be called solutions. And they're in the form of x, 0. So the output is always 0, but the input is some value. So we had the vertex down here. We had the y-intercept here. We had the zeros. Those are the important points we're going to use in our explanation. The vertex, the y-intercept, or the roots. Okay, so we've got three forms. We've got one called the standard form. We've got the one called the factored form. We've got one called the vertex form. Standard, factored, vertex. Supposedly each one of these has information in it that you can look at and instantaneously know the answer to. So each one of these is supposed to be able to give us certain pieces of information on that picture instantaneously. So in this first form, that information we're going to look for is probably going to come into one of those three locations, either the A, B, or C form. So in this standard form, A, B, or C is going to be the information provider to us. Okay, so we're going to look at this here and we're going to identify our special locations. So we identified a vertex and it is at -2, 1. We also identified a y-intercept at 0, 3. What we do notice is there's no roots. Now a root is an x-intercept. It's also a solution. So let's take a look. Just look at the information provided to me here. So we're going to look at the A spot, the B spot, and the C spot. Do I see a correlation between -2, 1, and A, B, or C? Do I see a correlation between the value 3 and A, B, or C? I see a correlation with the C. So when x equals 0, y equals 3. Let's see how that correlates to the equation up here. So if I put in a 0 for the x, what does my y equal? Y equals 0 plus 3, so y equals 3. So it looks like in the standard form, the piece of information that you can find just by looking at the equation is the y-intercept. That's good. Let's verify that with another example. Okay, let's look at this example. This example here. We have roots. We have a, they do not appear to hit at an exact location. So we're going to estimate them to be at a location of 1, 0, and estimate them at a location of -3, 0. Okay. Do we see the numbers 1 and -3 in the equation? In the A, B, or C spot? Nope. Let's see. Let's check our vertex. Our vertex is at -1, 7. Okay, do I see a -1 or a 7 in my A, B, or C? No. So what information am I going to get here? Let's take a look at the y-intercept, which is right here. My y-intercept is at a location 0, 5. So, now, is the 5 in there? Yes, it's in the C location. So if I plugged in 0 for x in both locations, I would get an output of 5. So the standard form of a parabola or a quadratic, the C location or the constant is always the y-intercept. That's handy. Form number 2. This one's called factored form. Need to give you a little bit of vocabulary here. I've been using certain words over and over again. Do you think what do you think the R represents in some of the words that I've been using before? Root, which is also the x-intercept. So let's go look at a picture and a couple of equations and see if we can find a relationship between that value and the picture. I'm going to give you a quick tip. We need to think about what this means. You know, that sign there. See if it's going to have any effect on it. Now, let's see here. I got a red one and a blue one. The red one's on top. Okay. So that red one, let's take a look at it. Let's see if we can. Okay. So that red one, we got a vertex. Our vertex is at what? -3.5. -3.5. Let's see, -3.5 and -2.2. Oh, I don't see those numbers up there, do you? Alright, let's see our zeros, our roots. We have -5, 0, -2, 0. Oh, they are there, aren't they? The 5 is there, and the 2 is there. Interesting. So, but they're negatives down here. Let's see if that applies to the second one. Let's take a look at this one. What value would make that 0? That would be a 3. Well, there it is. My x-intercept is 3. What value would make that 0? Well, it's -1. Check. Those are the two x-intercepts, or roots. So this form identifies the roots for me. So let's go look at this. So that was x plus 5 and x plus 2, but they were zeros. The values were -5, 0, and -2, 0. Let's see how there's a correlation. So let's take a look at just this part. So if x plus 5 gives me an output of 0, I solve it, and I get x equals -5. So it looks like the value that will make this 0 is the value of the x-intercept. Our final form is going to be what's called the vertex form. Well, amazing, amazing, amazing. One of these letters or multiples of these letters is going to tell me the vertex. So it's either going to be the A, the H, and the K, A and H and K, A and K, some kind of combination of those letters is going to tell me where the vertex is. Looking at that equation, I see, yes, it says opposite of H. So let's take a look. Alright, so I'm just going to focus in here. So that's a y-intercept there. That's at 0, 5. Well, there's no 5 in the purple one. Okay. I have a root and a root. My root is at -5, 0. 1, 0. Nope. So let's go straight to the vertex. Now, on my vertex, I have -3, 1, 2, 3, 4, -4. All right. Now, well, the -4 is obvious, isn't it? We can check that bad boy off in a heartbeat, can't we? So, yep, there's a -4 there, and a -4 there. So, so it looks like my vertex is going to use the K. So the -3, though, that's an opposite one again, isn't it? So let's get to this one. The opposite of 3 is -3. So I'm going to be using the opposite of H and K to give me my vertex. Let's see if that actually matches in the yellow one. So very quickly I look. Okay, so it should be the opposite of H, so it would be +6, and K, which would be 3. So I'll look over here. Yep. I circled the wrong part, didn't I? Shucky darn. Okay, here we go. Opposite of, let's see, opposite of 6, check. That wasn't that 6, and +3, check. All right. So a quick review. So if we have y equals 3x squared plus 2x plus 5, what information does this tell you? Y-intercept. Okay. Quick review. Y equals x minus 3, x plus 2. What information does this tell you? It tells you the roots. And the root is going to be related to the opposite of those two. So one root will be at 3, 0. One root will be at -2, 0. What information? What review here? 2x minus 5 squared plus 7. This is vertex form, so what information is going to be given to you? It's going to be called the vertex, which is the H and the K. But now we got to remember, it's the opposite of H and K, so that's going to be the vertex is going to be at 5, 7.